You are asked to determine the mass per unit length of a given wire by taking only one measurement. Mass per unit length by taking only one measurement using a sonometer and a tuning fork. Figure shows a standard sonometer setup in school laboratory fixed with the given wire. The wire is stretched with a tension T between two bridges A and B. In this setup, the bridge A is fixed and bridge B is allowed to move. Bridge B is allowed to move. That is important. We can't move both of them then only B is movable. This is fixed. Right? And only B is movable. This is movable. Right? The tension only B is movable, right? The tension of the wire could be changed by varying the load mass, right? This one. By varying this, additional masses are also given, right? Tension of the wire could be changed, right? So we know if this is mg, tension of the wire comes as T, 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 like this throughout, it will be T, right? A tuning fork with known frequencies provided to you, right? First one, what type of vibrations is produced in the surrounding air due to vibration of tuning fork in the experiment? What type of vibrations? They are longitudinal stationary waves, right? Longitudinal waves or longitudinal stationary waves. Longitudinal air mediums, no? Stationary vibrations or waves. Longitudinal stationary vibrations. If m is the mass per unit length of the stretch wire of tension T, write down an expression for the speed v of transverse waves using T and m, right? Our standard equation, right? V equals root T over m. V equals root T over m, our standard equation, the most popular equation. See, in the experiment, you are supposed to measure the resonant length L of wire resonating with the tuning fork at the fundamental note. The student suggested that there can be three ways ABC, keeping the vibrated tuning fork to obtain the resonant state, as shown in figure. XY represents a part of surface of sonometer box, right? XY is the surface of sonometer box. B, tuning fork held normal to XY and without touching, in B, okay. Now only I got it. Tuning fork held normal to XY without touching, right? Without touching. At B, means pen on without touching here, right? And C, tuning fork is held above the stretch wire. Okay. All right, wire is here. In order to obtain maximum amplitude for resonance out of the above three ways, which way would you select to keep the vibrated tuning fork? A, B, or C? Give reasons for your selection. Right? Popular question. That must be A. Must be A. When the tuning fork is kept on the box, on sonometer box only, it transmits energy. Right? It transmits energy to the sonometer box. Right? Otherwise, that propagation of energy or transmission of energy is not that rich. That is not rich. Right? We have to have a very effective or productive, efficient propagation of energy. Right? To increase that propagation, always it should be kept on the box. Right? Then write down. Answer is A. Selection is A. Right? Selection is A. Then have to write the reason, no? Tuning fork should be kept on the box for better propagation of energy, to vibrate air medium inside sonometer with maximum amplitude, right? This is the complete answer. should be kept on the box. Should be kept on the box. Right? D. Write down the other item that you normally use in this experiment to detect the resonance state experimentally. Right? Other item. Right? We have paper ideas. Right? Now always keep the experiment in mind. Paper ideas. Right? Paper ideas are essential. Otherwise, how to observe or how to identify the maximum amplitude? Right? So what happens is at the maximum amplitude, when vibrates, paper ideas are jumping off the wire. When they jumps off, then we identify that as the maximum vibration, maximum amplitude, right? Resonance. Then write down the main experimental steps that you would follow to detect the optimum resonance state. Right, optimum resonance state. Right, then have to write what I mentioned. Then write down. First, now paper ideas are not kept yet. No, we have to say that first, right? Have to keep paper ideas. Keep paper ideas. Keep paper ideas on the wire, on wire AB. Right? Keep paper ideas on wire AB. Right? On wire means around the middle, around the middle. On wire AB. On wire capital AB. Right? On wire AB. On wire AB. Right? Now, initially it was clearly given that only one is movable. Which one? Only B is movable, no? Then we have to move, right? We have to move B gradually, right? You have to adjust or move B gradually until paper ideas are jumping off, right? Then next one. Adjust or increase, adjust B gradually. Adjust B gradually, starting from a small length or a small gap, small length, small gap between bridges, from a small gap, from a small gap. Adjust B gradually, starting from a small gap until paper ideas jump off, until paper ideas jump off the wire, right? Next, obtain an expression for M in terms of F, L, and T, right? Obtain an expression for M. Now we know we have got the fundamental frequency. No, we have got the fundamental frequency. Then this is our fundamental wave pattern on the wire. This is fundamental wave pattern, right? One loop, no. So we know one loop is lambda 2. Then lambda 2 equals L. In this case, lambda equals 2L. Right? First of all, you have to find it. Lambda equals 2L. Then apply V equals F lambda. V equals F lambda. V is root TOM. Right? F is F. Lambda is 2L. Right? We need obtain an expression for simple lem. For simple lem, have to subject simple lem there. Then to subject simple lem, remove the square here. Right, see, remove the square here, then TOM equals, this side becomes square of 2 is 4, S squared, L squared. Subject M, then M equals T over 4 F squared, L squared. T over 4 L squared, F squared, L squared, right? G. If the resonant length that you have obtained in the experiment is small, how do you adjust the above sonometer setup in a suitable manner to obtain a reasonably large resonant length for given tuning fork? Right. Now again, go to this equation, then we can easily argue. It says root TOM equals F times 2L. No? See what we can do to increase L. To increase L, easiest thing to do is increasing T. To increase L, easiest thing to do is increasing T. Right? That's why these additional weights are also given. With the ribbon, additional weights are given, and in the description also it says that the tension of wire could be changed. Tension of wire could be changed, right? So that's the purpose. That's the purpose. Then what's the question? How do you adjust? How do you adjust? By adding more masses, right? By adding more masses to the how was it given? To the load mass. By varying the load mass, then by adding more masses to the load mass. Then answer is by adding more masses to the load mass. By adding more masses to the load mass. Load mass. Then tension changes. But if you write as by changing tension, no marks will be given because you can't change tension, right? Tension is something indirect or something happens after changing this. So what we do is changing the mass. No? Right? In structure, it is always, that's how you should write, right? What you do, what we do is adding masses. Due to adding masses, tension changes. That's true. But we can't write as changing tension, right? They are very critical when it comes to structural disease. When M equals 3.2 and F equals 320, the resonant length was found to be 25. Find the mass per unit length of the wire in kg minus 1. Right? We have the equation now. No? Plug in the equation M equals, right? For the equation here, maybe M equals T. If this is 3.2, right? T is 32. No? 32 over 4 F squared 320 squared, then L squared, L was 25, then 25 times 25 centimeters to meters 10 to the power minus 4. Centimeters to meters 10 to the power minus 4, right? A small simplification, I have to simplify. Then this is 32 times 10 to the power 4. 10 to the power 4 is 100 times 100, no? Right? Then here 4 times 320 squared, 25 times 25. By 25 this cancels, right? What is implication? Anything that you have to do. Then 25 times 4. Then 4 to 4 cancels. 25 times 4 again, right? Then 32 and make cancel and right? Then this is 32 remains here times 4 remains now. And this is 320 times 320 kilo. We can write it as 32 times 10, no? Sorry, 100, no? 320 times 320. I separated 10 to the powers. Then 32 to 32 cancels. 4 times 8 is here. 4 times 8. Then M equals 1 over 8. 10 to the power minus 2. 1 over 8 is 1.25. Right? 0.125. Then 0.125 means adjust the value 1.25. 10 to the power minus 3. 1.25. 10 to the power minus 3. That is in the standard unit now, kgm minus 1. Right? That's a small simplification. Yeah, that's it. Any questions? Any questions from today's things?